Hello everyone, in this video we are going to discuss about introduction to machine learning with Matlab. Here machine learning with Matlab, this tutorial focuses on machine learning with Matlab, which reviewed machine learning basics and introduced supervised and unsupervised techniques. Also learn how to turn a model into a predictive model by training it on new data, extracting features and generating code for deployment on embedded device. Then with Matlab and specialized toolboxes, we can develop, tune and deploy predictive analytics without extensive knowledge of machine learning or data science. This is the application of this Matlab with a specialized toolbox. Pre-built functions and algorithm supports specialized applications such as deep learning, computer vision, finance. Nowadays, the blockchain technology is coming under this finance, image processing, text analytics, and autonomous agents. Then this is the developed model of machine learning application with Matlab. To develop the machine learning applications, we have to consider and follow these important steps. The first step is access and explore the data, that is collecting the data. And second step is pre-process the data and extract features, preparing the data. Then third step is develop the predictive model, and here training and evaluating model is there. And then fourth step is optimizing the model, that is the developing the model, optimize the model to the model parameters, then final step is deploy analytics to your production system. These are the five important steps are there in to develop the machine learning application. Here here access and explore data means access and explore data to collect the data and extract the features, that is a pre-process and data sets and extract features steps here. Then developed model, train and develop predictive models, then optimize the model parameters to get the optimized model. Then this is the common steps involved in machine learning. There are the basic 5 steps. This is the get data from anywhere, sensors or any database it may be, right? Second one, clean and prepare manipulate data. And the next one, train the model, train and develop the predictive model. And then the next one, test the data. And finally try to improve the data by using this some specialized algorithms, Matlab algorithms, machine learning algorithms. Then this is the list of common machine learning algorithms. There are many types of algorithms are used in Matlab for machine learning applications. The following table lists the characteristic of popular classification algorithms. Here the first one is algorithm logistic regression. It is linear and both non-linear support vector machine operations. The linear logistic regression means good for small problems with linear decision boundaries. Then second algorithm is the training decision trees. The decision trees, there are general assessment is good generalist but prone to overfitting. Then next one, support vector machine with non-linear. This is good for many binary problems and handles high dimensional data well. Then next algorithm is nearest neighbor algorithm. This algorithm gives lower accuracy but easy to use and interpret. Then next algorithm is naive Bayes algorithm. It is widely used for text and including spam filtering. Next algorithm, important algorithm is ensembles algorithms. It gives high accuracy and good performance for small to medium sized data sets. Then finally the neural network is popular for classification, compression, recognition and forecasting. These are important algorithm. Nowadays we are using neural network algorithm. Then these are the essential tools for machine learning tools. Along with these tips, the common steps. The first step is access and explore data. What is where our work with signal, sound, images, and finance data, and text, geospatial, and other formats, input data, access data. So related products available for accessing and exploring data in Matlab is database toolbox, data feed toolbox, OPC toolbox, signal processing toolbox, and vehicle network toolbox. Then the second step for machine learning to develop the model, pre-process data and extract features. Here improve your models with filtering, feature selection and transformations. These are the related products available in specialized available in our Matlab. Computer vision system toolbox, image processing toolbox, optimization toolbox, signal processing toolbox, statistics and machine learning toolbox, system identification toolbox, and wavelet toolbox. These are all the toolbox exclusively for pre-process the data and exact features. Then the third step, develop and optimize the predictive model. Interactive app is available in Matlab. Interactive app driven workflows to train quickly and compare the models. These are the specialized apps and products for refining and tuning your model. First one is the classic classification learner app, and the second one is regression learner app. These are the toolbox available in Matlab, that is deep learning toolbox, parallel computing toolbox, and the static and machine learning toolbox are available. Then fourth step is deploy analytics to your productive system. Our improved model with the filtering, feature selection, and another transformation also using this deployed analytics. And here related products available for applications in Matlab: HDL coder, MATLAB compiler, and MATLAB SDK, MATLAB product server is available here. And then the first step is our first step is a machine learning model by using first step access and explore the database. The first step is data import and export, means a standard procedure in machine learning. Is a here the specialized tool available to import access and explore data by using import tool app. Import tool app it is used for import data set from file. Lets you preview and import data from spreadsheet files, delimited text files, and fixed with text files. We can interactively select the data to import and reuse the script or function that the tool generates to import other similar files. Then the second important app for access and explore data is a database explorer app. By using this app, we can configure, we can explore and import database data. It's a visual interface allows you to quickly pull data into MATLAB friendly table format without needing to know the Microsoft SQL programming language. This is the important feature of this database explorer app. For example, Landsat 8 database explorer app. This app allows you to explore USGS Landsat 8 data hosted by Amazon Web Services. Then the second step, pre-process the data set and extract features. Why do we pre-process the data? This is the common questions nowadays asking. The data pre-processing is a data mining technique that involves transforming raw data into an understandable format. This is the deep data pre-processing. Real world data is often incomplete, inconsistent, and are lacking in certain behaviors of trends, and is likely to contain many errors. For that data processing, we are going to use the data pre-processing includes cleaning, instant selections, normalizations, transformation, feature selection, and selection, etc. Then why feature extraction is important? Previous one is why do pre-process is important. Here why feature extraction is important in pre-process the data sets and extract the features step. Feature extraction eliminates the redundancy present in the type of measured data and generalizing during the learning phase. The generalization is critical to avoiding the overfitting the model to specific examples. Then feature selection is an important process. Feature selection is the process of selecting those features that are most relevant for your specific modeling problem and removing unneeded or redundant features. The common approaches to feature selection include stepwise regression, sequential feature selection, and regularization is the common approaches to feature selection. Then the third step, train and develop predictive model. Developing a predictive model is an interactive process. Involve these steps. First step is selecting the training and validation data. Second one is select the classification algorithm. Third one, iteratively train and evaluate classification models. First, we start with training and validation data. Before training actual classifiers, we need to divide the data into a training and a validation set. The validation set is used to measure accuracy. During model development, cross validation is recommended for small data sets because it maximizes how much data is used for model training and typically results in a model that generalizes better. The second step, there is a selection of classification algorithm. No single learning algorithms works for every problem. It may be differs for based on the problem created. Then and identifying the right algorithm is often a process of trial and error method. By using trial and error method only, we are going to apply the machine learning algorithms for selected applications. Then final step is iteratively train and evaluate classification model. You can then train classifiers in parallel and compare the performance on your data. Then fourth step is optimize the model parameter. There are common approaches focus on one of the following aspects of machine learning model development. The first one is tuning model parameters. Second, adding to or modifying the training data. We can add the training data or modifying the training data in this step. Then third step is transforming or extracting the features. And final step is making task specific trade-offs. In tuning model parameters, we can almost always improve the performance by changing key model parameters from the default settings. These are key model parameter changing is called tuning model parameters. Then second step is adding to or modifying training data. Adding training data helps until we reach the point of overfitting. And next one, additional pre-processing can remedy for any issues with the data itself that we have overlooked, such as corrupted data, outliers, or missing values. The third step is transforming or extracting features. By applying a reduction technique, such a principal component analysis, that is called as PCA, then LDA, that is linear discriminant analysis, or singular value decomposition. The SVD is the important transforming methods. Then finally, to further improve the accuracy, introduce bias and tune the model parameters. Introduce the bias and tune the model parameter to make the task specific trade-offs. Here this is the iterative machine learning process in the optimizing the model parameters. To further improve the model, we could try the same series of optimization steps with different algorithms. Since how much improvement the various optimization techniques yields varies with the algorithm, with the different types of algorithms gives the different types of result. That is the iterative machine learning process. First you start with the data set, feature extraction, and run the model and evaluate the model. If we evaluate the model with another technique, again go to different evaluate the model with feature selections. Also the run the model between evaluate model versus your run model. If you are not satisfied with this model, means again we are going to run the model with different machine learning algorithm. This is a step for evaluate in this process we are evaluating your model. If you are not satisfied with your model, means again you go to run this model with different machine learning applications. Here machine learning evaluate the model, again it goes to feature selection, then you run the model. In this process, in done through iterative manner, is called your iterative machine learning process. Finally, you deploy analytics to your production system. By using Matlab coder, you can deploy your analytics to a specific embedded system. That is, machine learning applications can be deployed into production systems on desktops, in enterprise IT systems, such as nowadays we are using cloud, either on-site or in the cloud, and the embedded system. We can deploy Matlab applications on servers by compiling the code, either a standalone application or integration with an application written in another language such as C, C++, Python, Java, or .NET. The Matlab code are specifically used to makes the deployment of embedded systems easy by automatically translating Matlab into C code. This is a important feature of this Matlab coder. The Matlab coder makes deployment on embedded systems easy by automatically translating Matlab into C code. Is a many embedded application required model deployment in C code only, so that we can use in Matlab coder for deployment of embedded systems. Thank you.